2019 matrices came under question 1, and the question says, given that matrix A equals 6, x, 2, and 3, find the value of x for which the determinant of A is 36. Hence, find the inverse of A. So we have matrix A with elements 6, x, 2, and 3. Then the determinant is given, which is 36. Question 1, we need to find the value of x. So bring the formula. Determinant equals A times D minus B times C. So this is A, B, C, and D. Okay, so the determinant is 36 because A is 6 times D, which is 3, minus B is x times C, which is 2. Now 36 equals 6 times 3 is 18, x times 2 is 2x, so we have minus 2x. 18 minus 2x equals 36. Okay, so I've simply swapped everything on the right side, taken to the left side, then what we have on the left side taken to the right side. Signs are not affected if you move the terms in that manner. Okay, so here I need to get rid of this 18, and I have to do so by introducing the additive inverse. So this is positive 18. The additive inverse of positive 18 is negative 18. So I'm going to add negative 18 to the right side as well as, the left side as well as the right side. So 36 plus negative 18. Negative 18 plus 18 will give us a 0, leaving us with negative 2x on the left side. Please, this is negative 2x, it's not positive 2x. So be careful with the signs, bring this sign as well. Then the other side we have 36, positive times negative is negative, giving us the 6 minus 18. So we have negative 2x equals 36 minus 18 is 18. Okay, so we need to get rid of this coefficient so that the coefficient of x remains to be 1. And we do so by dividing negative 2x by negative 2. Okay, so negative 2x divided by negative 2. What we do this side, we do the other side. So even there we'll have 18 divided by negative 2. So negative 2 into negative 2 is 1, positive 1, times x will give us x equals 18 divided by negative 2 will give us negative 9. 18 divided by 2 is 9, positive divided by negative is negative. So the value of x in this matrix is simply negative 9. If we were to rewrite it, we'll have 6, where there is x we put negative 9, then we'll have 2 there and 3. So this is matrix A. Going to question 2, we are told to find the inverse of matrix A. Okay, so the inverse, which is denoted by that, okay, so inverse is noted by that, is equal to determinant of A times adjoint of A. Okay, so 1 over determinant of A was given, which is 36, so it will be 1 over 36 times adjoint of A. So we look at this matrix, we swap the elements in the major diagonal, change the signs of the elements in the minor diagonal. So swapping the elements in the major diagonal, we have 3 where 6 is, and 6 goes where 3 was. Then negative 9 goes to positive 9. Negative 2 becomes negative 2. Okay. Then we multiply 1 over 36 by everything in that matrix. So we're going to have 1 over 36 times 3, giving us 3 over 36. Times 9, we have 9 over 36. Times negative 2, we have negative 2 over 36. 1 over 36 times 6, we have 6 over 36. These numbers can be reduced or simplified. 3 can go into 3 once, into 36, 12. 9 into 9, 1 into 36, 4. 2 into negative 2, we have negative 1. Into 36, we have 18. 6 into 6 is 1, and into 36, it goes there 6 times. So this is the inverse of matrix A. 2020, the question says, given that matrix A equals 5, 2, 2x, find the value of x for which A has no inverse. Then find the inverse of A if x equals 1. So 2020, we have matrix A with elements 5, 2, 2, and x. Okay, so in this question, they're saying the given matrix doesn't have an inverse. Okay, this means that the determinant is equal to 0. When the determinant of a given matrix is 0, it means that matrix doesn't have an inverse. Remember, when finding the inverse, we multiply 1 divided by the determinant by the adjoint of a matrix, then we find the inverse. So if the determinant is 0, when you divide 1 by 0, your answer will be 0. 0 times the adjoint, you get a 0, meaning there will be no inverse for that matrix. So this means that the determinant is 0. Now when the determinant is 0, how do we find the value of x? We simply use the same formula. So value of x, we find it by using this formula. Determinant equals a times d minus b times c. So a is there, b, c, and d. Substituting, determinant is 0. A is 5 times d, which is x, minus b is 2 times c, which is also 2. Okay, so we have 0 equals 5 times x is 5x, 2 times 2 is 4, so we have minus 4. Okay, I'll swap these. Solving for x, we introduce the additive inverse. So the additive inverse here is positive 4, since this is negative 4. So we add the additive inverse both sides. 5x minus 4 plus positive 4 equals 0 plus positive 4. Okay, so negative 4 plus 4 will give us a 0, leaving us with 5x equals 0 plus 4 is 4. Divide both sides by 5 so that we remain with x only. So 5x divided by 5 equals 4 divided by 5. 5 into 5 is 1 times x is x equals 4 over 5. So the value of x in this matrix is, when the determinant is 0, then the value of x is 4 over 5. So yes, if you try to find the determinant, you'll find that it's 0 when you replace x with 4 over 5. Moving on to question 2. The question 2 is telling us to find the inverse of A if x is equal to 1. Okay, so what this means is that matrix A will be 5, 2, 2, and where there is x we put 1. When you put 4 over 5 here, you will not find the inverse because your determinant will be 0. So to find the inverse, we are told that x is 1. So put 1 where there is x. Okay, so for us to find the inverse, we need the determinant. And in this case, the determinant is not given. What is given is the value of x. It's the opposite of what we've been doing in the previous questions. Okay, so determinant equals A times D minus B times C. In this case, determinant is not given. A is 5 times D is 1 minus B is 2 times C, which is 2. So determinant is equal to 5 times 1 is 5, 2 times 2 is 4. So 5 minus 4 will give us 1, meaning the determinant is 1. When x in matrix A is 1, then the determinant is 1. Now we can find the inverse. So inverse of A is equal to 1 over determinant of A times adjoint of A. Okay, so we have 1 over determinant of A. We found that it's 1 times adjoint of A. We simply swap those numbers. So we have 1 there, 5 there, and change the signs or multiply -1 by these figures. So we have -2 and -2 there. Okay, 1 over 1 is simply 1. When we multiply these, we multiply this number by the matrix, we'll simply have the same figures. 1 times 1 is 1, times -2 is -2. So we have 1, -2, -2 there, and 5 there. So this is the inverse of matrix A when x is 1. 2021 matrices came under question 5, and the question says, given that matrix P equals 1, 2, 2, and -x, find the value of x for which the determinant of P is -3. Hence, find the inverse of P. Okay, so for 2021, we are given matrix P with elements 1, 2, 2, -x. Okay, then the determinant is also given, which is -3. Question 1, we need to find the value of x. So the usual formula, determinant equals AD minus BC. Determinant in this case is -3 because A is 1, D is -x. So it's 1 times -x minus 2 times 2. We have -3 equals 1 times -x will give us -x. This is positive. Positive times negative is negative. 1 times x is x. Then 2 times 2 is 4 times that negative will have -4. I'll swap these. Have -x minus 4 equals -3. Okay, now I can bring in the additive inverse. So we have -4. Additive inverse of -4 is +4. So we have -x minus 4 plus 4 equals -3 plus 4. Negative x, negative 4 plus 4 will give us 0. So we remain with negative x this side. Negative 3 plus 4 will give us positive 1. When you are adding figures with different signs, where one is negative, the other one is positive, you subtract, then the answer gets the sign of the bigger number. So 3 is negative, 4 is positive. The signs are different, so subtract 4 minus 3. Okay, 4 minus 3, and that will give you a positive 1 because 4 is bigger than 3 and 4 is positive. Or you can use the number line. When we have a number line, we'll have negative 1 there, negative 2, negative 3, positive 1, positive 2, positive 3, positive 4. So using the number line, it means I'll need to start from where negative 3 is. So on the number line, go to negative 3, and negative 3 is here. Okay, then you look at this sign. This is a positive sign. It means I need to make a move to the right. Then how many steps? You look at this number. I need to make 4 steps. So from negative 3, I move to the right by 4 steps. So I'll have 1, 2, 3, 4. Meaning I'm going to find myself at positive 1. So this is the answer we found here. So you can either look at the signs, subtract, and look at the bigger number, or use the number line. Moving on, we cannot leave this here because this x is negative. We need to get rid of the negative. Remember, the coefficient of x here is 1. So this is negative 1. Divide both sides by negative 1. We're going to have something like that, so that this negative cancels with that one, leaving us with positive x equals positive 1 divided by negative 1 will give us negative 1. So it means the value of x in this matrix when the determinant is negative 3 is negative 1. So the matrix is 1, 2, 2. Then here we have a negative there. Negative, then our answer is also negative. So it will be like that. Okay. We have a negative there, then the value of x is also negative. So we'll put the signs like that. So the final matrix is 1, 2, 2. Negative times negative is positive, so we have positive 1. This is the matrix that will give us a negative 3 as the determinant. Okay, then number 2, we are told to find the inverse of p. So inverse of p, denoted by that, inverse of p will be equal to 1 over determinant of p times adjoint of p. Okay, so we have 1 over determinant of p is negative 3. So 1 over negative 3, then times adjoint of p. We simply swap. We have the same figures there, so even if we swap, we still remain with the same thing. We have 1 there, it will still be 1. Then the signs of these change, or simply multiply them by negative 1, so that we have negative 2, like that. So 1 over negative 3 times 1 will give us negative 1 over 3, negative 2 over negative 3, negative 2 over negative 3. Then we have 1 over negative 3. Okay, we need to deal with the signs here to still be the same, negative 1 over 3. Negative divided by negative is positive, so we'll have 2 over 3. Then negative there, we'll have the same thing, positive 2 over 3. Then negative 1 over 3. So this is the inverse of P. 2022 GCE, the question says, given that matrix n equals x, 2, 2x, and 6, find the value of x for which the determinant of n is 8. Hence or otherwise write inverse of n. So we have matrix n with elements, matrix n with elements x, 2, 2x, and 6. Then we are told that the determinant is 8. Okay, 1, we need to find the value of x. So the usual formula, determinant equals AD minus BC. Determinant is 8, A is x, D is 6. Then we have B, which is 2. Then C is 2x. Okay, so 8 equals x times 6 is 6x. 2 times 2x will give us 4x, so we have minus 4x. So 6x and 4x are like terms, therefore we can subtract. So 6 minus 4 is 2. Then bring down the variable the way it is. When you're adding or subtracting, the power of the variable doesn't change, just bring it the way it is. If it was x squared, you bring it x squared. X to the power 3, you bring it x to the power 3. So in this case, it's just x to the power or just x. So it's simply 2x. So we have 2x equals 8. We need to remain with x alone. So divide both sides by 2. 2x divided by 2 and 8 divided by 2. 2 into 2 is 1. 1 times x is x. Then 8 divided by 2 is simply 4. So the value of x in this matrix is 4. Matrix n is simply 4, 2 times 4. Then we have 6 there, giving us 4, 2, 8, and 6. So that's the matrix. Then we are told to find the inverse. Okay, so the question says, hence or otherwise write n to the power negative 1. This is simply the inverse of n. Okay, so we know how to find the inverse of n, denoted by this. The inverse is denoted by that. So inverse of n equals 1 over determinant of n times adjoint of n. 1 over determinant of n is given, we have 8, then times the adjoint of n. Swap that, we have 6 there, 4 there, then change the signs. Positive goes to negative 2, negative 8 goes, positive 8 goes to negative 8. Multiplying these, we have 1 over 8 times 6, giving us 6 over 8, negative 2 over 8, negative 8 over 8, and 4 over 8. We can reduce these figures. 2 can go into 6 3 times, into 8 4 times. 2 can go into negative 2 one time, then into 8 4 times. 8 into 8 is 1. This is negative, that's positive, so it will be negative 1. Then 4 into 4 is 1. Into 8 we have 2. So this is the inverse. So I wanted to talk about the inverse, the relationship between the inverse and the matrix, and why we said when the determinant is 0, then the matrix will not have an inverse. Okay, so the inverse of a matrix is a matrix whereby when you multiply it with the original matrix, you end up with what we call the identity matrix. And the identity matrix has got elements like 1 0 0 1. Okay, so this is the identity matrix. So when you find the inverse of a matrix, you multiply the original matrix with the inverse, you end up with the identity matrix, which is in this form. Okay, to prove that, if we look at the question we are just from dealing with, we have matrix N, which is 4 2 8 and 6. Then we found that the inverse of this matrix is 3 over 4, negative 1 over 4, negative 1, and 1 over 2. So if we multiply the matrix N with its inverse, what we need to get is the identity matrix. Okay, so bringing this, we have 4 2 8 and 6. Okay, and 6. Then we are multiplying this with 3 over 4, negative 1 over 4, negative 1, and 1 over 2. So multiplying matrices is row by column. So 4 times 3 over 4 will give us 3, plus 2 times negative 1 is negative 2. 4 times negative 1 over 4 is simply negative 1, plus 2 times half is 1. 8 times 3 over 4 will give us 6, plus 6 times negative 1 is negative 6. 8 times negative 1 over 4 will give us negative 2. 6 times half will give us positive 3. Okay, so adding those, we're going to have 1 there. 3 minus 2 is 1. There we'll have 0. Here we'll have 0. Negative 2 plus 3 is 1. So this is the identity matrix when we multiply matrix N with its inverse. So going back to 2020 question where the determinant is 0. So when the determinant is 0, you will not find the inverse. Okay? You will not find the inverse because 1 divided by 0 is 0. 0 times adjoint will still have a 0. So you will not have a matrix which can give you an identity matrix when you multiply with the original matrix. So that's all about matrices. We've looked at questions from 2016 to 2022 GCE. Okay, 2018 and 2022 we've looked at GCE past papers. The rest have been internal. So the next video we'll look at another topic.